Hello everyone, welcome to the channel. So in this video, I'm going to show you identifying an optimal town location through a raster based suitability analysis in ArcGIS. So now let's get started. So in our previous video, we have performed a vector based suitability analysis, and in this video, we're going to perform a raster based suitability analysis in identifying an optimal town locations in ArcGIS. So now let's get started. So this time we're going to approach the suitability analysis from a raster perspective and see if we can do a little more from weighting the each location standpoint. We're going to give a weights for each of our layer for each of the subclass. So instead of just saying yes or no, this area works. So we can discourage an areas and we can encourage other areas and see which area have the most preference for them versus against them. So first, instead of using extend polygon, this time we're still going to use raster for our analysis, but we're just going to make it to geoprocessing here. We're going to navigate to this option here. So in that, we're going to select this particular option, that is environments, so that everything only happens in that area. So in that, we're going to navigate to this option here in the output coordinates, and in that we're going to set our output coordinate system. So we're going to select so I'm going to set the output coordinate system to match the DEM here. So we're going to click the same as the layer DEM. So next we're going to navigate over the second option here, that is processing extent. So that all of our raster processing happens exactly in this coordinate here. So now we're going to set our processing extent as same as DEM. So same as a layer DEM, and similarly we're going to navigate to snap raster here. We're going to select DEM. So our snap raster to be same as our DEM, so our cell size always aligns. So next we're going to navigate to the option called raster analysis. So in that, in the cell size, we're going to select same as a layer DEM, and now in the mask, our analysis mask will also be same as the DEM, so we're going to select DEM. So we will only process the cells that are in line with the DEM cell, and now we're going to click OK. So now we're going to click OK. So and that way, whenever we run any geoprocessing tool, it will pick up those geoprocessing environments, and we will get the cell that align. So the first thing maybe we want to do is to get these vector layers converted to a raster layer, so that we can use them in our analysis. And the kind of easiest way to do that is in a lot of these cases is to do a Euclidean distance from all of them. That maybe we want to know how far we are from the roads and how far we are from the rivers, because those are the preference we might want to be closer to. But we can also use that to do distance from protected areas, and for example, the protected area distance of 0 means that we can't use that area, but and maybe we actually want to be close to the protected areas too, so that we can include that as a preference, because they may be that recreational locations for people. And similarly, finding our distance from the other urban areas could be a positive or a negative weighting factor. And again, doing a distance of 0 means that we can't build there. So now in case of the floodplain, being close to the floodplain is good, because it means that we are close to a big river that people can use for for commerce and recreational purposes. But being in it being at 0 means that we are the disaster or the risky zone. So we're going to run a Euclidean distance on all of this to start with, and get a new layer back. So for that, we're going to navigate to this option here, the Arc toolbox. So in the Arc toolbox, we're going to navigate to the option called Spatial Analysis tool. In that, we're going to navigate to this particular tool called distance, and we're going to click the this particular tool called Euclidean distance. So Euclidean distance, it calculates for each cell the Euclidean distance to the closest source. So now we're going to select our input feature. The input feature will be our major river here. So now here we're going to choose our output file location. So I'm going to select my file location. So here I'm going to enter the name as river distance. So now I have entered as river distance.tif. We're going to click save, and now we're going to click OK. So now here you can able to visualize we have our river distance raster. Similarly, we're gonna perform the for our roads layer too. So we're gonna insert our all rivers. Let me select roads here. Second, we're gonna select our roads layer here, and now I'm gonna choose my output file location. So here I have entered as road distance.tif. We're gonna click save, and now we're gonna click OK. So now here you can able to visualize our tool has run. So our road distance raster here, and now similarly we're gonna insert our urban areas too. So I'm gonna insert the existing urban areas. So now let me save to my folder location. So now I have entered as urban distance.tif. We're gonna click save, and we're gonna click OK. So now you can able to visualize our urban distance layer has been generated here, and we're gonna select our protected areas. So in the input raster, I'm gonna select the protected areas here. Let me save to my folder location. So now I have entered as protected distance.tif. We're gonna click save, and now we're gonna click OK. So now we have our protected distance layer here. So now we're gonna select our floodplain. We're gonna perform the similar analysis step here. Let me save to my folder location. So now I have entered as floodplain distance.tif. We're gonna click save, and we're gonna click OK. So now we have our protected layer protected, that is floodplain.distance layer here. So I'm gonna make this loop raster this time out of the DEM that we can use in our analysis. So for that, we're gonna navigate to our Arc toolbox section. In that, we're gonna navigate to this option here in the surfaces, and in that we're gonna click this tool called slope. So the input raster will be our DEM here. So let me select my DEM file, and now choose the output file location. So now here I enter the name as slope.tif, and we're gonna click save here, and now we're gonna click OK. So now we have our slope raster here. So now we have all our rasters, and now I can turn off the vector layers. Let me turn off my vector layers. I'm going to turn off the major rivers, roads, and existing urban areas, and protected areas, and floodplain. So now I have a slope raster and the floodplain, that is our distance rasters like floodplain, protected areas, urban, and roads, and river. And we have our land cover data here, and DEM. So I have all these criteria, and I can use to find my suitable town location. So now in this case, I'm going to do a suitability analysis that doesn't exclude any location explicitly. We instead just going to find the places that have more good things and a fewer bad things. So what I'm going to do is I'm going to come up with 3 points, a scoring system for each of this raster, and say maybe the slope of 0 to 5 is an excellent, and that's 3 points, and 5 to 10 is kind of okay, and it is 2 points, and anywhere above that between like a 10 to 15 is 1 point. So you can able to take a look at this point here, that is different classes for the slope. Based on that, we're going to give a values, and above 15 we just don't even want it, so it's a 0 point or something like that. That may not be what if you are in construction, and then maybe 15 is just a massive slope, and you just don't even bother that point too. But we will use that for the purpose of this example, and we will do the similar things for our distance, the distance to floodplain, and the distance to protected areas, distance to urban, and distance to road, and distance to river. And once we have the 3 point scoring for each of this, we can then sum them up and find the best location for our new town. So to do that, we're going to use a reclassify tool, and we're going to navigate to the Arc toolbox here. So we're going to navigate to Spatial Analyst. In that, we're going to navigate to this tool here, Reclass, and we're going to select this tool called Reclassify. So now let me input raster will be, first input raster will be our slope here, and make sure that your reclass field is our value. And now we're gonna navigate to this option here, classify, and in that we're gonna select the number of classes to be 3. And now we're gonna break the values here. We're gonna first enter 5, and followed by we're gonna enter as 10, and next we're gonna enter 15, and we're gonna click OK. So now here you can able to visualize the values here. I'm gonna reverse this value. So for 0 to 5 we're gonna give a score of 3, and for 5 to 10 I'm gonna give a score as 2, and for 10 to 15 let me enter the score as 1. And now let me add a entry here. So you're gonna enter as from 15 to 70. The maximum value is around 70 here. Now let me enter the values from 15 to 80. So I have entered as from 15 to 80, and make sure that you give some space in between this, and let me enter the value as 0 here. And now let me save to my folder location. So now I have entered as slope suitability.tif. We're gonna click save here, and now we're gonna click OK. So now the tool has run, so we can able to visualize here the slope suitability. So you can able to see here. So I get this reclassified slope raster. So now let me make some changes to it. We're gonna navigate to the property. We're gonna change the color of this particular layer here. We're gonna navigate to symbology, and we're gonna click the stretch type, and let me select a suitable color ramp. So you're gonna select this particular color ramp here, and you're gonna click OK. So here you can able to visualize the highest level of values. The suitable slope locations are 3, and the not suitable slope locations are 0 here. So the red spots indicates you could see that we are excluding a bunch of areas here, the red areas, but then we have a plenty still in consideration with our slope raster here. And I will do something similar with the rest of the raster. So we're gonna let's do the floodplain distance here. We're gonna navigate to the arc toolbox. We're gonna click reclassify again, and we're gonna input raster will be our floodplain distance. And now here we're gonna click this option here, classify, and in that we're gonna select the number of classes to be 4. So now we're gonna break the values here. First let me make 0, another maybe 300. Let me enter 300 here, and the next will be around 600. And now I'm gonna click OK. So here the 0 is a 0 in this case here. I'm gonna enter 0, and from 0 to 300 is really close, but not in the floodplain as a grade. So let me enter. So let me enter as 3 here, and from 300 to 600 I'm gonna enter 2, and the rest will be is 1. Now let me save this file to my suitable folder location. So let me enter as the floodplain suitability. So now let me save this, and now we're gonna click OK. So now we have our floodplain suitability, and we will do something similar to our protected areas. So we're gonna click reclassify, and the input raster will be our protected distance. So now we're gonna classify it, and we're gonna set the number of classes to be around 4, and let me enter the first value to be 0 here. Now next I'm gonna enter as this particular as 1 kilometer, and now next will be 2 kilometers. So now we're gonna click OK. So now the value is 0, represents a 0 kilometer. So we're gonna enter as a value of 0, and for 1 kilometer we're gonna enter the value as 1 here. So that is close to 1 kilometers. We're gonna enter as 3, and close to 2 kilometers we're gonna enter as 2 here, and for more than 2 kilometers we're gonna enter 1. And this is scoring for our protected distance layer. Now let me save to my suitable folder location, and now I'm gonna save as a protected suitability. So now I have entered as protected suitability, and we're gonna click save, and now we're gonna click OK. And now we have our protected suitability layer here. So now we're gonna reclassify our river here. So in our reclassify tool here, we're gonna select our, and now here we're gonna select our river distance here, and now we're gonna classify it. So number of classes, we're gonna make it so 4 classes. So here we will say maybe within 300 meters of our river. So let me change this to 300. The next will be 600 meters of river, and next will be our 900 meters of river. And now we're gonna click OK. So from 0 to 300 meters, we're gonna give a value of 3. And for 300 to 600 meter, which is further away from the river, we're gonna give as 2. And similarly, which is furthest away from the river, that is 600 to 900 meters, so we're gonna give the value as 1 here. And from 900, more than 900, we're gonna enter the value to be around 0. So now let me save to my folder location here. So I have entered the name as river suitability.tif. We're gonna click save here, and now we're gonna click OK. So now we have our river suitability layer here. You can able to see that. And now let's do to the distance to road here. We're gonna reclassify tool, and we're gonna insert our input raster will be our road distance here. We're gonna click this layer, and we're gonna reclassify it. We're gonna classify it, and the number of classes to be 4. And maybe we want to be within 500 meters or 1000 or 1500. Now let me enter 500 here. So now we have entered 500, 1000 and 1500 meters for the targeted scores. So now we're gonna click OK, and now we're gonna call this as 3, the highest score, and followed by 2 and 1 and 0. Now let me save to my folder location. So now let me enter as the road suitability.tif. So now I have entered as road suitability. We're gonna click save, and now we're gonna click OK. So now here you can able to visualize the result, the road suitability.tif here. So this is the road suitability. Similarly, we're gonna select reclassify, and now we're gonna select our urban distance. Let me select this, and now we're gonna click this option here, classify. And once again, this is something that where maybe we decide based upon that judgment called whether or not want to be close to an urban area or further away. So in this case, let's say we want to be further away from the urban areas. So now let me select the number of classes to be 4 here, and now let me enter the value here as a 1 kilometer. So I have entered as 1 kilometer, and similarly I'm gonna enter here as 2 kilometers and 3 kilometers. And now we're gonna click OK. So here in the values within 1 kilometers, it is unacceptable for this case here. So we're gonna enter the value of 0 here, and similarly within 2 kilometers it is OK. So for that we're gonna give a value of 1 here. And now for within 2 to 3 kilometers, we're gonna give the value to be around 2. And now within 3 kilometers, we're gonna give a value of 3 here, which is better, and further away is best for this particular layer. And we can call this as an urban suitability. Let me save to my folder location. So now I have entered as urban suitability.tif, and we're gonna click save. And now we're gonna click OK. So now we have our urban suitability. So now here you can able to visualize we have our urban suitability layer here. And now here you can able to see in the protected unsuitability there is an error in this particular layer. It is not reclassified. So let me run this particular layer once more. So for that we can navigate to the Arc toolbox here, and we're gonna click reclassify, and the input raster will be the protected distance here. So let me select this particular file here. So here we're gonna navigate to this option here, classify, and in that we're gonna select the number of classes to be 4. And now here we're gonna select the value to be 0 here, and next. we're going to enter the value to be 1 kilometer, that is 1000 meters. And similarly, the second class will be 2 kilometers, and that is 2000 meters. And last, we're going to leave this value as a default value here. So now let me click OK. And now let me click this option here, change the missing value to no data, and let me save to my folder location as protected suitability. So we entered as a protected suit means suitability, and we're gonna click save. And now here we're gonna give it a value here. We're gonna enter the 0 kilometers as 0, and within 1 kilometers we're gonna enter the value as 1 here. And similarly, for between 1 kilometers to 2 kilometers, we're gonna enter the value to be 2. And more than 2, we're going to enter the value to be 3. And now let me click this here, and now click OK. And now here you can able to visualize we have our protect suitability layer here. You can able to see the layer here, it is reclassified correctly. Now let me remove this layer, and now I'm going to rename as a protected suitability. So now I have renamed as a protected suitability. Let me turn off the protected layer here, this one. So now the last one is land cover layer here. Let me show you that. So this is our land cover layer. Now let me drag this particular layer to the top here. And now this is our land cover data. You can able to visualize it. So now we have our urban areas marked, but the land cover raster also has its own set of urban areas. You can able to visualize from the image. The red areas indicates the urban areas. So you can able to visualize from the map. The red indicates the urban area. So maybe we don't want to build along anything marked on the urban area in there as well. You can able to see that. Or we potentially, if we are trying to preserve the agland, because the county had so this particular county has no laws of agland which exist in some places in this study area. So we might want to exclude that type of land cover too, but in this case, let's just exclude any other urban areas based upon this land cover from the raster here. So now we are looking at the land cover. One thing we didn't include in the original one is anything based on the land cover. So maybe we want to make sure that we get all the urban pixels are excluded. And or something like preserving an agricultural lands, we want to make sure that that has a weights for it too. So what we can do is to use the land cover raster to maybe to subtract the value from places that are agricultural and add a value to other places, and subtract or leave the urban areas at 0. So here these brown and yellow areas from the legend or agriculture, they are the cultivated crops and pasture land. So let's track some values from there, and then let's also subtract the value from the values from the open water designation, which is number 11. So let me show you here. This is our Vancouver data. So open water represents the number 11 here. So these are in 80s, and this is in 11. So you can able to see from this particular value here 11, which represents the water, open water. Then let's make the urban areas neutral and everywhere else positive. So now we will use our reclassify tool again. So we're going to navigate to this option here and click this reclassify tool. And now I'm going to select the input raster will be our land cover data. So let me select land cover 2011. So for example, let me select the value 11 to 12. Let's subtract 3 from them. So for that, we're going to add a value here, minus 3. So we basically can't build that other open waters and snow or the perennial snow. So for that, we have given a value of minus 3. So total scoring will be 3. So as a result, minus 3 and plus gets neutralized. So kind of we want to put this particular value in negative. So next is the values from 21 to 24. Now let me select the value 21 to 24 here. 21 to 24, which we want to be neutral. So for that, we're going to give a value of 0. So there is the urban area, so we don't want to gain any score there. And then we have values between 31 to 74 that are potentially a buildable space. So let me enter the value here. Those are different land covers there, so let's add a 2 to those value here. So now I have added 2. And then for 81 to 82 here, 81 to 82, we also want the agland here. We want to preserve the agland here, so let's subtract by 3 here. So we have subtracted by 3 to put the preference for keeping the agland. In that way they can stay in production. So this particular study area has an ordinance in certain counties that you can't lose the production in agland. So now let me add a new entry. Now let me add a 90 to 95 here. We will also leave as a positive for this particular range here. We can potentially build there, so but maybe a smaller positive. Those are the 90 to 95 are wetland. So now let me add a value 1 here. So maybe we don't want to have it as a big of preference as for the rest of this, for this particular value here in the 90 to 95. So now let me save to the folder location, and I'm gonna enter the name as land cover suitability. So now I have entered as land cover suitability and click save. So I have to reduce the length of this particular word here. So now now we're gonna click OK to run this. So now we have our land cover suitability layer here. You can able to see that. So we get our values here. So we have our -3, 0, 1 and 2. And now let's put all this layer together. So for that we're gonna navigate to raster calculator. So open your arc toolbox and click this option here called map algebra. We're gonna click raster calculator. So now let's add this layer. First let me select the land cover suitability. We're gonna click add a plus sign here, and next we're gonna select our urban suitability. Let me click this, and we're gonna add a plus sign here. Next we're gonna add our road suitability layer. We can add a plus sign here, and after that we're gonna add the river suitability, add a plus sign, and next we're gonna add our floodplain suitability and plus sign. Next we're gonna add a protected suitability, and followed by we have our slope suitability. So we're gonna add this to my folder location. So now I entered as combined suitability. I'm gonna click save. So let me reduce the length of this word here. So now we're gonna click OK. So now we have our combined suitability layer here. So you can able to visualize from this particular result. It's kind of hard to see because it gave it a unique value classifier here. So to do that we're gonna stretch type. So go to the properties here. So now let me select the stretch type here, and let me give some color to this particular layer here. For now let me we show it in the grayscale here. We're gonna click OK. So now you can able to visualize the result here. So we can see that the higher values are that are the places that we should really considered for new town location, and the lower values are the one we shouldn't consider. So you can able to see from this particular raster here, the high values are represented in the whitish area here, and the low values are represented in gray color here. You can able to see that the most suitable and ideal locations are highlighted in the white color. You can able to view that the high values are represented in white color. You can able to see from this particular raster here, and the low values are the one we shouldn't consider for the new town locations. So here this area I think popped out in a vector based analysis too. This particular area was we saw in the previously in our vector based analysis. So we are seeing this as a more positive location, this particular area. And also we can see this particular spots here also has a higher values, which are indicates the most suitable town, optimal town locations. And I think it is because this is near the river and other floodplain, our floodplain outside of here, and also big protected areas in here. I think so. Let me turn on the protected areas here. You can now able to see that. Let me turn off the other layers, so you can see the floodplain areas here. Let me turn on the protected areas here. So we can see that shadow from not getting any positive in there. So not getting many positives in there. So here you can able to see we have this kind of a continuous surface, or approximately continuous surface, suggesting where we might consider putting our new development. But it's not an absolute, but it tries to help us to decide by showing us better and worst places to start looking for where we want to put our new town. So in this video I have basically have shown you identifying an optimal town location through a vector based analysis, vector based, that is a raster based suitability analysis. The ways I have shown you in this video is raster based suitability analysis, and in the previous one I have shown you the vector based suitability analysis. And I just want you to just this understand this particular concept, and it's not always about locating suitable town locations or building new town locations. It can be anything about that you're trying to set a spatial criteria for and figure out better and worst locations for, whether it is theoretical or predictive, or whether it is looking to put something there or find something. So in this video I have shown you identifying an optimal town location through a raster based suitability analysis. So thanks for watching, and please subscribe to our channel and give us a like.